Glad. Okay. How many people here work in industry of some sort? Okay. I was going to actually turn this off because I was curious how many people here, like, what do you want to get out of this? Or should I wait till later? Okay. Okay, so for those coming late, I just sent an email about, you should just gotten the email like 2 seconds ago, but all the code for this tutorial is at this website. It's a GitHub, so you can either clone it, fork it, clone it, or download it as a raw, whichever, or view it online, whatever makes you happy. So I know I just asked about how many of you use Matplotlib. How many of you, when you use Matplotlib, you use like the figure object and object-oriented Matplotlib? 2? Okay, that's convenient. Then well, a lot of this will be new to a lot of you then. Okay. Sure. I just posted it on the class notes website, so if you go to the website for this, you should be able to just click on it. Let me just see if my computer. That didn't help. It's github.com/story645/matplotlib tutorial. Okay, which, first day of class, I always ask my students, I'll ask you, how many of you registered for the Matplotlib tutorial? Like, you're in the right room? Yes. Okay, great. Okay, okay, so I'll give you all, then let me give you all another minute to get full down. Everyone get settled. Okay, I'm going to just wait. Okay, so so this is your warning, focus, whatever. The focus of this tutorial is gonna be basically a crash course to doing very object-oriented Matplotlib, and the reason for that is to get anything nice out of Matplotlib, you need to go object-oriented. Like if you stick to the other way to do it, it just goes all messy. So let's talk about what does object-oriented Matplotlib mean first. Okay, I'm assuming all of you know what object-orientedness is? Okay. So Matplotlib has 2 ways to do things. One way is a remnant of the fact that Matplotlib was originally copying MATLAB, which is an engineering-ish thing, and it's all procedural. So the way you usually see Matplotlib done, that plot dot figure, right? And then plot dot plot and etc. That's a remnant of doing this state-based MATLAB way where procedural, where we have one step, we create the canvas. We have step 2, we add an axis on top of it. Step 3, we add the plot on top, and we're layering them all on top of each other, kind of like a sandwich. And so what happens is, because you're doing this sandwichy thing, it gets harder to pull out pieces to inspect them. What we're doing instead, the other way to do Matplotlib, though, is what's called this object-oriented way. And there, the idea is we create a figure object, just a plain blank figure, and then we attach to it. Like we make basically our graph has a tree structure to it, like any other object. It'll have the figure to it, then it'll have any axes that we're attaching to it, and then the axes will all have their properties attached to that. And so let's start with the figure. This is figure.py. By the way, let me know if I need to make the font bigger on the code. And so in a straight basic figure type deal, first we create a figure object. We'll do, plain object, then we'll attach a canvas to it. Canvases are, come into play when what we talk about is when we're talking about what we're vendoring to. And so what we mean by that is, this case we're using AGG as the backend. What that does is that's the thing that actually draws the pictures, and it'll give you back the image. The reason we care about a figure canvas is different backends support different functionality. The functionality, like AG will support PDFs. I think one of the other ones doesn't. You'll have the Tinker backend, which you need to use if you're trying to make an interactive Matplotlib that you're going to stick in an application. There's the HTML backend now if you want to make a web-based Matplotlib. So and that's the other reason to do this object-orientedness way, is because then you can print your figure to these different canvases that you can then embed in new tools. So we create our canvas, and then we just print to the canvas. We print the figure, and in this case, we're just going to make it. And so this code, it's really boring. If we run it, I'm pretty sure. If we run it, it just creates a plain canvas. I made it gray so you could see that it's plain, but so that's a straight, plain, kind of blank slate on which we're going to now draw our math. Okay, so I should have organized this better. Okay, now so let's start layering on the pit math, or the axes. So the axes are what you guys are used to as thinking of actual Matplotlib plots. That's the thing with the X and the Y and the Z on which you're going to start drawing your visualizations. And so we do a .add subplot. All plots are always, basically, you always want to make things a subplot of your plot, of your figure. And the reason for that is it gives you more control about where you can move things. Because then you have this kind of little sub-object that you can push up, down, left, right as you need it on the canvas. So we're just going to add a subplot. This comes from Matplotlib land, MATLAB land. And it's the number of rows and the number of columns that we're going to end up having of subplots, and then the position of this specific subplot. If we just want one, that's going to be the blanket, the entire page. It's the 111 token. And again, we're just going to print the figure. Okay. And you see, like I said, all it does is it adds. We have numbers now. Right, but this isn't so interesting, right? We'll want more numbers. By the way, stop me if you have questions, because I don't want this to just be me talking at you, especially if you're confused. Yeah? It's all on GitHub. Okay. And the link is on, I just posted the link for course announcements. I think I did. Yeah. Yeah, if anybody's a little bit late. Great. Perfect. Okay, so we have that. Yeah. Yeah. Oh, you make it. That's what this is going to be a little bit of pain. Yeah. This is what the print figure is doing. It's creating that PNG. For you guys, you shouldn't do the // figures / because that means I'm saving all of this stuff in a folder named figures that's above the folder the code is in. But yeah, the print figure is what actually saves it. For those of you who've done Matplotlib before, this is savefig. This is just the canvas-oriented version of savefig. So it works the same way and takes all the same arguments. And the reason for that is because that old savefig, that was working on the state model, and it was saying is we're going to take everything that's currently all of this stuff that's currently like resting on top of each other as a states, and we're going to smash it together and, shove it out for you. Okay. Okay, I know this. I'm looking for something named subplot. Oh, here. Okay, so now this is the subplot. This one I'm actually gonna run first because it'll be easier to show you what it does. Okay, so subplot generates subplots, gives a whole set of them. And again, like the big subplot, we're gonna just keep adding subplots to our figure as needed. We're gonna start, in this case, 2 rows, 3 columns. And the reason I wanted to give you multiple is just show you that the counting goes just straight across. It's almost S-shaped, straight back. And what I mean by that, so things in position 1, that's axis 1, this is at position 2, position 3 as you go down. So when you start making like big tables, you just have to keep that in mind for the layout. Questions yet? Okay. Oh, and so there's this thing that I commented out, but fig.tight layout. What that is often, but not always, if your subplots start looking a little bit squashed, the tight layout will clean it up and unsquash it. It goes a little bit back and forth. Okay. Okay, so I'll just flat out. Okay. Oh, so let's grab. One of these days, right? I'll give samples names. So what I want to talk about now is, right, we have our subplot, we have our axes, so we have these pieces, right? But let's start talking about this guy and, our axes. Because the thing is, again, because it's a tree, those axes, there's objects of our big axes. And they're each little objects, and they have their own methods attached to them. And so we want to start isolating them. Okay, so, and I have no idea why this thing is doing that. Okay, so the way we're going to isolate them is, there are 2 ways to do this. The way we're going to talk about the other way later, but the way we talk about now is, actually, I guess we do both of these. We either do this AX1 dot x-axis or dot y-axis, where we're calling a specific method the specific sub-object of our axes, and then on there, like, we're doing a method like grid, and so that's how we'll turn on the grid for the x. And so that's one way where we're going to access it directly. And the other way we can access our axes is we can do a lot of these methods. They'll have names in them like set x label or set y label or set z label, and you just do the method set underscore which axis you want and modify it. If we want a 3D graph, we need to set a projection equals to 3D, and we need to import the 3D axes, which is a subclass. But what will happen is Matplotlib will like namespace glom it onto everything else, so you don't need to call any specific methods. Okay. Questions on this yet? Which green thing? Oh, the grid, it's turning on, that's great. It's turning on, it's actually really pale here, but it's turning on grids. Like if you want, yeah, the vertical and diagonal grid. Well, yeah, I'll turn on a vertical grid, but if you want to turn on the grid for the whole space and you don't want it just for the x-axis or the y-axis, you just do a1.grid. True, the name of your axis and dot grid. Yeah, you don't need to subclass it. The other thing is that you often want to do is just set the limits, and what that does is it restricts the space of your graph to the numbers. Okay, so that's kind of like, okay, we have our axes now. Let's plot some data on it. Started plotting data on it. And so we have our most basic data. Our poor little point. Oh, wait. Of course, I forgot something. Okay, spines. So the deal with them is we're not married to our axes. Looking the way it does, we can customize it as needed. So if I want to change the colors of my spines, if I want to get rid of 2 of them because those are the type of graphs I want, I can just set them. The idea is we pull up the spine. It's a method on the axis again, not a method. It's an attribute of the axis, these spines, and then we can just set the right spine, the top spine, bottom left, and we can set the color we want it, or we can always set it invisible, which is what's happening at the bottom. Okay, so I guess, let me just, point. What I want you to take away from this, though, is that nothing about this, like you're not married to any of it. If you want to get rid of something, change it, change the color, change the line, change the color, the width, the shape, whatever, there's a property in Matplotlib that'll do it. You just kind of have to dig into documentation, but it all kind of works the same way of the object, the meth property, and you set it somewhere. And Matplotlib is this very Java influence that there are getters and setters for everything. But because it's Python, it also has everything is public, right? All objects are public, so you can kind of, if you find like a getter and setter isn't working, you can brute force it too. Not that I recommend that, but okay. So points, right? Let's make a little point. If I can ever find anything. Okay, we can make a basic point. We use a scatter plot for this. We can have the position, and again, we can make properties of it. And that's not so interesting, right? Making a point. But what is interesting is kind of all the things you can do with it. For one thing, your points don't have to be clear. And this kind of, well, 3 things I want you to know. Let's see from here. One, the colors. Pink isn't one of the listed ones, right? So the thing with Matplotlib, it can take any color under the sun. you can put in, if it's an HTML, if it's an official HTML color, or it has an HTML number to it, you can just pop that in and it'll draw it. It'll render that color. It doesn't, like it's not married to that red, green, blue, magenta list. It also doesn't have to be, actually, sorry, I'm gonna make this easier. CMD, C. Okay. It also doesn't have to be, I forgot the word for it, but it can be transparent. You can have like walls of transparent dots, and it doesn't care. It's the alpha value. And that's because all colors kind of, Matplotlib kind of lets you have the standard ways to manipulate your colors. Okay. But like I said, right, this isn't the interesting part. The interesting part is kind of what can we do with these? Let me see if I. So we have lots and lots of options for markers. We kind of actually have a kitchen sink of options for markers. We can make squares and triangles and dashes and dots, and you can also make custom markers. Literally, the rule for the custom markers is you have to give the number of values you have and the number of angles you want. And I think, and the number of sides you want and the angles you want, and whether it should be a star shape or a pentagon shape. These are all the raw markers. Keys, and what I mean by that is that if you do like marker style equals 2, you're going to get that dash. And if you do marker style equals H, you're going to get the hexagon. It's a straight shot. So let's actually pull this up, because there's another thing I'll probably do with this. Okay. So okay, so that's what, like I was saying, that this M, which is what we're printing out as a label, that's the thing you pipe into your scatter and to get that image. The other thing is if you have a line plot, you can put in a line and you just do the marker style keyword argument, and it works the same way. Oh, and the annotations. We haven't talked about, you'll see this annotation stuff all over the place. And Matplotlib has 2 options if you want to throw text on your page. You can either do just a straight text, ax.text, and that'll give you, tell it the x position, the y position, and what you want, and the text, and it'll throw it on there. Or you have the annotate, which lets you have arrows, and it'll draw your arrow correctly. And if you want annotate, you can and give it the words you want. You'll give it the, I forgot what this was called. The position of the data, the thing you're pointing to, the position where you want the words. And then you have what is called this BB box. The BB box, and this shows up all over Matplotlib when you're talking about shapes. And what it is it defines how that shape should look. It tells us if it should be rounded or should be square, if it should have a white face color and black edges, black face color. All of the properties of your annotations go in that BB box. And then you have the arrow props, and this is the same thing that Matplotlib will let you can customize the arrows kind of to your heart's content. If you look in the documentation for arrows, they have the whole list of things you can do for that. Okay. Oh, and in this case, if you just need to like quickly clear out ticks, you can just blank it out. It's a shorthand. We'll later into longhand.
So
Yeah.
you've got a bunch of different series you
Yeah.
got a plot and you want to like iterate over the different marker styles,
Yeah.
would you just pick them up like you've done here? I noticed that some of them are doubled up and stuff like that.
This is actually the raw list from like their raw list, but a lot of them do look like they're doubled up. So what I would suggest is,
Just manually make a quick list of those.
yeah, or combine print out that list and then edit it, copy it, and then edit it. Yeah.
When you're using the Canvas all interface, how do you put it, make it go to an interactive figure?
Plot.show. You still, if you put a plot.show at the end, it should do it anyways.
So you do Matplotlib.
Yeah. Or you just will import, or actually no, because it's pyplot.show. So let me actually see. This is easier, right? Not this one isn't. It happens to not be interactive. Sorry, I never make my stuff interactive anymore because it's not worth it. I know Matplotlib has pyplot. Okay. Yeah, sorry, I'm like spacing. Okay. Okay, it didn't like that. Maybe, but I don't think it actually cares. But yeah, you can do it. Let's. Yeah. I guess because this way you're completely bypassing the state interface. So since you're bypassing it completely, it's just not going to want to show. If you really want that interactivity, what I would suggest, then just do it this way. Then it's not so bad. What you do instead is fig equals plot.figure, and that's it. Yeah. And then this plot.show at the end. And the reason for this is kind of the whole point, is that when you do this plot.fig, plot.figure, even though it seems like you're doing this object-orientedness thing, you're actually still throwing this up as a state. It's that quasi-hybrid model that does weird things. Which, by the way, Matplotlib lets you do. Like, if you need to be in that space or comfortable in that space, go for it. But yeah, you just do fig equals plot.figure, and then you can do a plot.show at the end, and you'll have your interactive figure. This is useful a lot of times when you're plotting 3D data, like 3D scatters, and you want that rotation. You can also make a GIF, though. We can talk about that later. Okay. So we can do that. Other thing we can do is, right, so we have all these options for style. We can also, our size, we can make these things pretty big. Oh, and if I don't close this, it won't let me do stuff. Here. No, where? Oh. Okay. Okay, so the point is this is just like, we can make the size up to infinity, down to nothing. You just do s is equal to size. Oh, the other thing you can do, the thing I keep forgetting, is you can just do this. Size, you can pass an array into size. So if you want to make these variable sizes based on some variable you have, it'll just let you do it directly. And let's, okay. see. And let's set s is equal to I. Yeah. So yeah, if you ever need your scatter size to vary based on your data, it just gets fed in as another. So you can almost treat this as a way to make, basically you can almost treat this size as like if a way to do your to plot your third variable. It works like an X and Y. Okay. So that was, okay. Lines don't, so there's, I think next is lines. If I can. Okay. So lines don't have quite as many options. Lines have almost no options, especially when you consider that 3 of the options are none. But you can also use anything you can use for marker, you can use for line. And the idea is instead of doing line style, you do marker style, and it'll plot, that plot will plot that marker along the way. But besides those, you can also use line style. And your options are dash, double dash, dot dash, and straight. Like I said. And again, with lines, you can change the color or the width. The width is the weight. Okay, questions yet? Okay, so let's actually talk about putting all this together. And of course, I'm pretty sure, so I think I'm putting this together in something brutal. Yeah. Okay. So we're putting this together in a 4-plot. The reason for this is so how many of you have seen 4-plots before? Okay. A 4-plot is used in data analysis because it tells you the distribution of your data. The idea is supposed to give you a feel for the distribution of your data. That's what the histogram, straight is just going to be that straight. What values do we have? The time series analysis. The lag plot this is a lag plot, and it'll tell you the correlation between your data and your data 1 day back. So if I take my data and then I take my data and offset it by 1 and do a correlation, that's this plot. And this is what's called the normal curve plot, normal probability plot, and it tells you how normal your data is. And so the way this one works is you take the standard deviation of, not standard deviation, so you take your data, you sort it, and then you evaluate your data, look at a probability distribution over the same values as your data, and you plot one against the other. And so it's kind of like the correlation between, it's basically the correlation of a Gaussian distribution over your values and the actual distribution of your values. Yeah.
Sorry, what should it look like if the data's not?
This data is random. So for random data, yeah, it's straight and there's no correlation. Because this data is random pulled from a normal curve. Okay, so let's break down how all of those pieces we just talked about go into making something like this, right? Okay, so the way I do it is, because this is kind of painful, is we can make functions for our axes. And so the thing is, because an axis is an object, the axis can be passed as an argument to a function. And so let's do that, right? Let's isolate just the axes. And the big reason I'm isolating just the axes is so that I can do that I can do the plot where they're all on the same page, and I can also make individual of these things at the same time. Which, I don't know about you, but I have to do a lot. Right, so we'll start with just that and our dates and our data. We'll we'll set the title and the label, which again, take the axis, just add it on. Then we'll use what's called the v-lines function in axes, and what it does is v-lines just draws a vertical line. That's all it does. I think I'm doing that just because I didn't like the grid. You can use the grid instead, and then we'll just plot the dates against the data, set a marker style for lines, and set the color to that HTML color, because like I said, it'll let me. And then I went all custom on the date ticks because Matplotlib has this function called plot dates. It usually works except when it doesn't, right? And so when it doesn't, it's often easier to just manually go in, set. So the thing is, and this will actually, I think, be the next thing we'll talk about. The thing is with the ticks is that you can just manually say, hey, I want this here, 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 and here. And you can manually say, hey, I want these labels. And just throw it down and it'll do it. It also has smarter ways to do this that we'll talk about. We'll set the limits, we'll set the auto scale. So this auto scale is the same thing as the plot.type layout. They all kind of work the same way. So we'll bake that in, and then we'll do this other plot, which is the lag plot. And again, it's kind of like, it's a raw scatter, that's all it is. So we'll just do a scatter of our data, one against the other, and we'll set our limits accordingly. Histograms don't get enough love. So what nobody realizes, the Matplotlib, right, will have the histogram. It'll let us set the color and the edge color. It also, if you guys want, if for some reason you don't want the blocky histogram, right, you just want the edges, there's an option called hist type. And you can set your his type to like step. And let me show you. I don't know. I think it's cool because I used to do this by hand. Right, so we set our his type to his step. And then we'll just have an outline. And so the upside of this is that if you need to start comparing histograms, you can just compare them all because you can just plot one and the other. So that's that one. That's that with the step. Okay. This probably again is just a scatter plot. Like they're not all that complicated in terms of plots. Okay, this is what I wanted. This is the meat of this, though, right? How do we put it together? Well, now that I have these all as individual axes, I can create my figure, call each of the create the axis, call each of the functions, put that on that axis, and then it's done. Like that's the thing. You don't have to return an axis, right? You just attach. The idea is you're just passing these in and attaching to your axes as it goes down this path, and it just gets, it's kind of like, how many of you know what's it called? Pass by reference? Python objects are passed by reference. So what that means is anything you do to the object stays even after that function call. Okay. So we're going to attach, and then we're just going to print it because we're done. And like I was saying, the reason to do this is also so that I can just write a for loop to make all these. Yeah? What do you?
Find yourself writing a utility to have a class that, it annoys me that you always have to repeat the same thing over and over again.
I think you don't have to anymore. I haven't looked like really closely, but I think I was reading somewhere in the documentation that they've added something to this. Yeah. 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 So, yeah, look through the documentation. I think they may have gotten rid of it. Otherwise, it's a great patch, right? Actually, send me an email about it and I'll see about doing it. But I think I mean, it's not hard, you're right, because all you do is inspect the figure that called the axes. And you can find out what the layout is. You just have to make sure that you've told it at least once, hey, I have 4. What you can do is also, there is this factory function. This is the other way to do it. There's a factory function that creates all the plots at once. It's like fig.subplots or fig.gridspec, and it'll just create all of them in one shot, and then you don't have to worry about it. Okay. Okay, so I think, so that wraps up the basics, like, right, how do we do these basic things? But basic, run-of-the-mill plots, nothing too complicated. Right, now let's start going into, well, that's fine, but that's, right, we need more graphs, So I think I'm gonna do, I think, the inverse of how I said it was. And what I mean by that is, like, let's start like tricking out all of these little ticks and locators and stuff, just so that because as you guys saw in the sample for the time series, right, the default just wasn't working, so we're going to have to go in and change it anyways. So this is the joy of, Matplotlib has a whole class for this. It's called, and I think it was, I thought I put it up here. You obviously see where my focus is. Okay. Okay. So it's the ticker API. It has a whole class. Anything you want to do with your ticks, it's going to be in ticker. The most basic parts of it are, and this is kind of the thing you have to get if you're going to start messing around with them, is they have their locators and they have their formatters. Because ticks have 2 components to them. Ticks have where they are on your graph, and they have what label are you attaching to them, right? Makes sense. So tickers have the formatters. Formatters are to make your labels pretty. Locators are to make your ticks go in the right place. And so let's start with formatters. I have no idea what I'm looking for here. Okay. Okay. So there are a couple of types of formatters. There's the null, which means that I don't want one. I just need a blank. This is for when that ax.set trick doesn't work. So null, fixed and format string are the 2 you're probably using most often. Fixed formatters are when you want the raw labels. Format string formatter is when you need like to clip the position, right? When it's like trying to print out 1,000,000 numbers and you only want 2, like 0.02 or at floating point set. Scalar formatter is the default, and what it does is Matplotlib tries to be smart about how you want stuff formatted. And function format, log formatter works the same as scalar formatter, which is for log numbers. And what was it? Oh, function formatter is literally you're applying a function to, we'll talk about it. Like that one is you're making a custom formatter based on your values, essentially. Okay, so basic formatter. For fixed formatter, like I was saying, it's where you're setting the strings directly. So you empty a class, fixed formatter, and then what our label should be. And then on the axis, we set the major formatter. We have major and minor. Major is the dark ticks, minor is like smaller ticks, and they're kind of the in-between ticks. You know how you'll see sometimes big teeth and little teeth on the graph? So this is the major is the big teeth, minor is the little teeth. And then we'll have a format string formatter. In this case, I'm just saying like value is equal to delta. And what'll happen is it'll replace my value in here. It's going to set. No idea what this thing is called. Oh. Yeah, it's kind of like the most uninteresting. So, like, because I said, because I told it use these, and because I told it use, I told it, hey, use those names, use those names. But here's what's really important, because it's going to mess you up. It's just, and this is true with the set tick labels, is that if you tell it to set raw and you don't give it the locations, it's going to go all wrong on you. Because what it does is it counts like the first n values and just assigns them to any ticks you've put down. So we have to correct that, right? Because it's bad if our ticks don't match our data. So this is where locators come in. And what a locator is just, hey, this is where the tick is. I can find anything in here, that'd be great. Okay. So like we have fixed formatters, we have a fixed locator. A fixed locator says, you know, I want 10 ticks, I want these ticks at those locations. And again, we just tell it, let's set that locator down. If we have, and so we have a fixed locator, which is like, hey, these are the places you have to listen. We have what's called the index locator, which is set a tick at every second or third or fifth or some base, set a tick at those places. So in this case, set a tick at every third interval. And it has an offset. In this case, 0. Our offset is where we should start counting our offsets from. So in this case, so this says like the first one's going to be at 3 and then at 6 and 9. And so if we run this one now, run this one now. Now we see, right, our locators are at the bottom. It's all, we have all 9 of them now, all 9 of our labels. And if we look at a y-axis, we have every third value. And the other thing is, we didn't have to touch our formatter, right? That's because when you're dealing with the index locate, when you're dealing with anything that's not fixed, it'll automatically fill in the gaps and link the two up. Okay. Let's talk about this. And so, yeah, we have a couple of options here. You can do a linear located, and that's kind of like using a linspace on your data. Like if you wanted linspace to be your ticks, you use a linear locator, and you'll pull that in there. Multiple locators similar to index locator, but it's like if you want something exponential type of deal going on, log locator. And like if you say, I don't know, like if you just don't know your data, but you know you can only, like you only want 10 ticks for cleanness, there's the max n locator. And what it'll do is say like, here, 10 ticks, you figure it out. Okay. No, and I hate it. Yeah. Yeah. Again, that's probably one of those things like they would love, Matplotlib would love it if somebody, you know, patched their code to the new. No, it crashes and burns. What he's talking about is, how many of you know the new Python string thing? How many of you have seen, like, you know, quote, brackets, dot format? Yeah, so Matplotlib doesn't support that on its format strings. For Matplotlib format strings, you have to use old C style, printf style, parentheses, D. That's what this parentheses C stuff is. It's old C style format strings.
By the same token, it probably has a global for the decimal separator, right? Whether you want to use dots or commas.
Oh.
You're doing percent D or percent F.
If it's going to be in a, I mean, all the Matplotlib globals are in RC params, so you can probably just print that, print that. See? Okay, what was I gonna, what else was gonna, I have way too much stuff in here. Sorry, I will dump these into folders on GitHub because I'm realizing now this is unreadable. Okay, so, oh yeah, so a basic thing is that you sometimes want to put math, right? You're dealing with a mathematical equation, you want something in your label to have math in it. Matplotlib is really simple about this. They say just put an R before it and just do, and you can use LaTeX directly, and it'll render your LaTeX just fine. Just put an R and then a $/alpha=/beta, or whatever. Put in all your tech, close the $sign again, and it'll render fine. Way too many of these. Okay, and so this one, it just renders as, if I can, and so it'll just render as alpha=beta up top, like I was saying, clean. Oh, the other part of this is, yeah, if you're dealing with titles, like if you're dealing with any of the, if you're dealing with any of the set properties, set title, set X label, Y label, Z label, set X tick label, set Y tick labels, any of those will take font properties directly. So if you want to change the font size or the color or whatever, you can pass those in as arguments to any of those functions, and they'll just do their magic. Like, no questions about it. If you want to deal with, if you're dealing with formatters, though, they get a little bit crankier. They won't let you can't pass formatting into it directly. But what you do instead is there's a function called tickparams, and you do call ax.tickparams, and you either set it for one axis or both axes, and you can set the color and the label size and the tick size and all of that directly using that function. Okay.
That's for just the AX question, right? The same things for.
Well, no. So the AX tick params, you have to explicitly tell it which axis you're working with. But because it's a keyword, you can just do, if you leave it out, it'll do both axes automatically. It's kind of the deal at once. Okay. I have no idea what this thing is even called anymore. If I can. Yeah, so this one, we wanted to make it red, so we just set it to, we did the tick parameters, and I'll just change it up. Okay, is that it on these? Okay, so that's it for the axes property stuff. Does anyone have any questions on that before I jump into the wild world of color? Okay. So let's talk about color. I like color. Do you like color? And so when we start talking about color, we have to start with RGB color. So The idea behind RGB color is that we're gonna take all our colors of the universe and we're gonna say that all of them are really some mix of red, green, and blue. We'll control how much red, green, and blue, but they're all really just red, green, and blue. And so that's what these cubes are about. If I let a little bit more red, I get very red. If I take away a little bit of red, I get closer to black. So black is I take away all the colors, white is I add all the colors fully. So when we see these red, green, blue color styles of like 0.0, 0.1, 0.3, you know, and these three triplets, that's the color. When we look at HTML color tags, color tags are just an RGB triplet. All they're doing is saying, I have this much blue, red, this much green, this much blue. And this is why Matplotlib is fine with your HTML, right? It'll just take it and pull out that RGB and pull it. So like I was saying earlier, if you have a point or a dot or a line and you just want it, and like you hate the built-in colors, you know, I go to Google, I look up a color table, I'll print the color. And we can do that right now. So one of the sites I like for this is called Color Lovers. It, you know, we can just like, let's make a pretty neonish color, right? So we can copy this. Let me actually close everything. Okay. Actually, we need to go one further up from this. Right, so let's paste this in. Actually, and let me first clear out my figures folder so we can find things easily. And now I have a neon green dot. So the colors you can use on Matplotlib are only limited by kind of what RGB color space supports. And this is not just true for the dot. We'll talk about how we can do this in actual maps, right? Because that's where it gets interesting. Okay, but first let's talk about the basics of color maps. And so first let's talk about how color maps come in multiple types. I like Colorbars for figuring out what kind of color maps I should use. But the idea is, our data itself is either sequential, diverging, or qualitative. And color maps should match accordingly. And the deal is, so sequential data, right? Our data monotonically increases, decreases, but there's no like split, hey, this tells you this data goes this way and that way. Diverging data is like our data, you know, we have some median, and we're interested in how far our data goes away from some median or some mean, right? This direction, that direction. And so we'll choose a color map. So if we look at our sequential color maps, right, they're all gradients. They all go from like some very pale thing down to something very dark. If we look at our diverging color maps, though, right, they have some white center, some yellow center. The idea is on a diverging map is I should be able to look at my data directly and see, hey, weight data opposites, right? And then we have, no idea what qualitative data, and the idea behind qualitative data is the color maps are all scattered around because the data itself is. Like this could mean, you know, I don't even know. Like this could be something like census tract or demographics majority or something. Any of this in non-numerical data usually, but if it's numerical data, your numerics are binned. They're not telling you something about the relationship between these values. So the reason I'm using Colorbars is because all the Colorbars maps are supported in Matplotlib. And this is the other fun thing about them. You can get colorblind safe and print friendly and photocopy safe. Which, depending on your audience, it might be important, right? Especially the colorblind. Okay. Yeah, if you guys, so if you want, we want the list of Matplotlib. If you want a list of color maps, this is not actually it. 1 second. Yeah, so Matplotlib has like, I think like 30 color maps it'll support now. All your regulars, it's called color maps reference.py. do the regular sequentials, it'll do diverging, it'll do qualitative, it'll do miscellaneous. One of the interesting things is, like, if you're in the Earth and Atmosphere community, because of their Matplotlib adoption, a lot of their color maps are now baked into Matplotlib directly. Is anybody here in Earth and Atmo? Yay! Okay. So let's talk a basic, right? Okay, so a basic color map, right? We have our 3 color maps. Does this look like it's the same data to you? So this is why color is important. This is the exact same data. It's the same random data, but we just changed the color on it. And this is why you have to start. This is why, like, when you're working with data and coloring it, you always need to think about, like, is my data sequential? Is it diverging? Am I kind of lying to my audience with the way I color it? Also, the other thing you need is, can you tell anything about this data right now? What's it missing? Legends, right? Oh, but actually, first let's talk about this. Okay, so if we want to just show the data, it's called the imshow command. Imshow data, and you name the CMap. And you can directly use the name that's on the Matplotlib website. So in this case, blues, reds, RDBU. But yeah, color bars. Color bars are important. And thankfully, Matplotlib cleaned up how they do color bars really recently. Okay, so let's see. Sorry. Okay, so now we have color bars. Right, it's still kind of ugly. But at least now we know that really white is negative 3.2, or really red is negative 3.2. And now we see, right, that's all the same values. So how do we add the color bar first? Well, all we do is, the idea is we take this axis, it'll create what's called a scalar mappable. Whenever you see, how many of you have seen an error message, hey, missing scalar mappable type thing? Okay, if you do enough Matplotlib, you will see this message. So scalar mappables, those are the actual images. Like, that's the plot that you're looking at, that line graph or that map graph or whatever. In this case, so when they're talking about scalar mappables, they're talking about this matrix here. They're talking about the colors they're talking about what are called the colors associated with they're talking about the colors and the numbers associated with this thing and how they all mesh together. And so what we want to do is we want to return the scalar, so calling this will return the scalar mappable. We then just feed that into a .colorbar method, and then colorbar, using the scalar mappable, it'll pull out all this information to make your color bars line up with your data. So it'll take care of the accuracy for you. But this is kind of hideous, right? We shouldn't do that. So that's easy. Color bar takes options. So we can do options, let us shrink things. Did you really not go? I think I lost something. No. Okay. So what we can do is we can pass in this fraction. And this fraction lets us say, hey, that the color bar, it should only be some percentage of the graph. I think 0.045 seems to be the magic number that'll get you at the same size. So yeah, pass in the option and you now have a color bar that's the same size as your graph. Pass in the orientation if you want your vertical graph. Decrease the padding or increase it as needed. Right, okay, so we have this and it's kind of boring. So, you know, what kind of things can we do with this now? Okay, have it all lined up. Let's see, I forgot. Did I do this? Oh, actually, first let's start. Once you set the color bar, you can then it'll return a color bar axis. And that's how if you want, so color bar axes work the same way all our other ones do. So we can then do a cbar.set label, cbar.set ticks, cbar.set x tick labels, y tick labels, whatever. So if you got your color bar and then just want to change it all up, you can do it using the cbar object it returns. The example here. One of these days, right? Okay. Yeah, so that's just letting you label things. Okay, what was I going? Right. But I promised something more interesting than this, so let's talk. Okay, so clip, custom. These are the CMap clip, custom, and discrete. Okay, but first, though, to talk about customization, we need to talk about color maps themselves and how do they work. And so here's where the two parts that go into a color map, and they're separate and really important because they do different things. Start, we have an actual color map. These are the colors we want to use. It's that list of colors, that red, that green, that blue, whatever. It's just raw list of colors. The second part is what's called the normalization. And the normalization is how we go from that list, it's the map. It says that, because remember, visualization and colorization, all it is I'm taking the number in my matrix and I'm arbitrarily assigning it to a color. That's all these visualizations are. So the normalization tells me, or tells the program how we're going to take the numbers in your matrix and we're going to assign them to a color. The reason it's called normalization is because that color map, it works on a 0 to 1 scale. That's where its head is at. And so you're taking your numbers and you're mapping them onto the 0-1 scale. So we have that normalization. And so one of the things we'll want to do first is, let's say, okay, I have a lot of numbers in there, but let's say I only really care about the numbers between -1 and 1. So one of the easy ways I can do this is I can normalize to -1 and 1. That'll build out my color map, so everything, only the values within -1 and 1 map into the color map. And then what I can do is I can do that, and so that's what I'm doing here. I'm saying, hey, let's normalize that and we'll norm it. And the next thing I want to do is, we lose data when we do that, so we should try to be honest. And so what we can do is Matplotlib lets us extend the color bar. And what it'll do, let us extend the color bar and set these unders and overs is you can, once you have that norm clipping, you can say, hey, but everything over all my outliers, set them to this color, and all my other outliers, set them to that color. And then the color bar will pick that up and it'll tell, and you can flag basically it gives you a way to flag your outliers within your visualization. And if your subplots are all kind of getting crowded on each other, there's a fig.subplots.adjust, and you can adjust the W space or the H space to just let them uncrowd. Yeah, sometimes you have to do it manually. Okay. And, this back propagates. If you set a cbar2.cmap that's set over and set under, it'll go back to the actual color mappables, and it'll color your data the correct way. So let's run this. Okay. I think I just did the wrong one. Yep. So, like I was saying, either way, here, I think the first time, what did I say? I'm a little bit confused. Okay, so that's what it's doing here too. It's really hard to see on this actually, but it's coloring all of our unders and our overs yellow. Our unders yellow, our overs green in here, and then you're just having these extents to add it to the sides of your color bar. Oh, and you guys see that it's less dotty now, right? It was kind of blurry and now it's in focus. That's a keyword argument called interpolation equals the nearest. And interpolation equals nearest. And so what it does is it renders your matrix pixel as a pixel in your image. Just, or multiple pixels, but it'll look through that matrix value and apply it. Because otherwise what it tries to do is like fuzzy soften it so it'll blend into the other values in your matrix. So, which is also, if you're using this for like raw data visualization, like of those value type, always use interpolation equals nearest, because that's going to be the most accurate representation of what's actually in your matrix. Okay. Okay, but right, so we see this, and now, but now that this is so clear, right, this is still fuzzy. So what we might want to do next is let's bin these, right? Because also maybe we don't care about the like difference between 0.4 and 0.8, right? Maybe we only care about 0, 1, 2, you know, very like wide swaths of numbers. And so we want to discretize what's called discretizing our data. And what we're doing there is we're taking all our values and just putting them into these rough bins. And so this is where I was getting at, that it's really, really simple to make custom color maps. Matplotlib has this function called boundary norm. And what it does is it literally sets up the norm with the values you give it. You give it this A range, or you give this list of boundaries. Basically, you give it this list. I want values between here and here, here and here, here and here, here and here, here and here. So that's this list here. And then you give it cmap.n, which is just, it's built into CMap. It tells you the number of colors in CMap. And that's it. You pass that norm and that CMap down into your im shows. And it'll come out and, hold up. Yeah. See, you pass those into your im shows and it'll come out and it'll clean up that data. It'll bin it to these discrete bins. And now you have a cleaner data visualization. The other thing is you want to do, if you're working with contours, if you'll pass your contour maps into the color bar, it'll automatically give you these discrete bins that line up with the contours. Right? But what if all this isn't good enough, right? What if you're like, but I really, really want to use this like shiny color that's on some shiny color somewhere? Well, that's listed color maps. There's a function called linear segmented color map. Do the from list. You can also do this raw where you're hand coding the 0, 1 RGB values. So you can get that, but 90% of the time, it's like, if you give it a list of numbers you want, colors you want, you just pass in that list, you give it the norm scheme you want, and it'll do all the interpolation to get all your between sets too. So in this case, I'm just doing this raw yellow, green, this raw 3 colors. I have no idea what. Okay. I have no idea what I'm looking at. So I pass in my raw 3 colors, and it'll just, I have 2 of these things going on here. Yeah, so the first time I'm just passing in these 2, values, and I'm setting it, give me 3 between there. The second time I give it 3 values, and so this time where I don't have it in between, it'll interpolate and it'll fill in your missing colors along that gradient. And on the second one, I'm just saying, hey, I have these 3 colors. These are the 3 bounds I want, and it'll assign things as needed. So that's really all there is. So like I was saying, all there is to that is this linear segmented color map dot from list method, and you give it a name. It doesn't care what the name is. It's totally arbitrary, and you give it that list of colors. You're done. So again, what are we going to apply it to? We're going to apply this to a bubble chart, because bubble charts are cute, right? Okay. Okay. So remember I was saying that scatters, you can pass in your size as a variable to scatter? Well, you can also pass in your color as a variable to scatter plots. So if you want a gradiated scatter or a raw scatter, what you do is you pass in your value to color. Color is equal to some array. And then you pass in a color map. And if you pass in your color map and set up your norms correctly, scatter will take care of all of the underlying engine will take care of all of the assignings and everything, so you can get out your bubble graph. I know, there's just not much to this. Okay. And when I'm using the MP again, this is just random data, because why not? What was I gonna say? So questions before I go into. Actually, I want to just stop right now because the next topic is a little bit different. Questions yet? Okay. I feel like I just dumped a lot of information on you all. Okay, so how about, yeah? Okay. 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 Yeah, sure. Let's break this down. Okay. So first what we're doing here is with this A, B, C, and D, is we're just setting up these we're setting up our data. Our data is going to be 4 lists of random numbers. And I'm doing a permutation just to shuffle it so I don't have 4 straight lists of numbers. Then I'm creating the figure, attaching the canvas. Then here, so there's this library CM, and it's the Matplotlib color map library. You can import CM. I'm importing matplotlib.cm as MCM, and I'm doing .spring. So now I'm having the the spring color map, just one of these color maps. And then I'm saying, hey, I want to discretize this color map so that every value between 0 and 1 is one color. Every value between 1 and 2 is one color. Every color between 2 and 3 is one color. 3 and 4 is one color, right? So that's the these are the boundaries that say, hey, this matrix shuffles into those colors. It's like a paint by numbers kit. Then, okay, to our figure, we're going to add the subplot, this 1, 1, 1, that does, and that just sets up this kind of drawing table for our actual plot. And so now this scatter, there's a lot going on here, actually. You're right. It's packing, all the stuff about a bubble chart is in this one little line of code. So let's unpack this. What's happening here is that A and that B, that's the X and the Y of the scatter. It's a traditional XY, and that's, That's all this. Now, but now here's the third part. That's C. That's the color. And so traditionally the way bubble charts work, the idea behind bubble charts is they're supposed to give you a way to kind of visualize 4D data. The idea is your x-axis and the y-axis each have a piece of information on them. Then the size of the dot has a piece of information attached to it, and then the color of the dot has a piece of information attached to it. And so what we're saying is, in this case, that information in that color, that we can code that. We can code that as a raw number attached to it. So this C that's in the array of numbers. That's going to be our third piece of information. But they're going to take that array of numbers, and because we've set up our norm and our color map, we're going to color those depending on how our paint by numbers kit, our normalization, said we should color those values. So that's what's happening with this C and this C map and this norm. It's all these three pieces of lines of code are saying, hey, this value, this is how you should color these values. And then we have this. The D is just our value D. We can again pass in a list of numbers D, and that's our size. I thought they were kind of tiny, and also they start at 0. So that was okay, I'm going to scale all of these values by 10, and I'm going to multiply it by 50. And it's just to make these dots bigger so they show up. Because the thing I've kind of learned is that anything I do, like anything you do for publication, shows up miserably on a PowerPoint. And so like you know, the kind of tip is like you always need to like make all the line weights thicker, all your dots bigger, etc. Okay, and so that's all that's doing. It's saying, I'm going to take this dot at that x and that y. We're going to give it this color and we're going to give it this size. And so we set the scat to this. Again, that's that whole scalar mappable. This scat, it's kind of the idea is that we've created this thing on the axis. This scat is kind of that baked in scatter. It's kind of, the way to it's kind of this baked in object that has the axis in it. It has all this information about like what colors we attach to it and what values we attach to it and everything else. So the idea is that we need this scalar mappable object, this pre-baked thing with the colors and the colors and the norm attached to it, because we're going to then give it to the color bar. Because the color bar, it needs that information to then make an accurate color bar. Because the other way you can do this is you can tell the color bar, hey, this is the color map I'm working with, and this is the boundaries I'm working with and stuff. But it's simpler if you can just pass that in directly. And again, so here we're saying, giving it the axis, because we're saying, hey, make this color bar, put it on this axis. And we're telling it fraction. It's kind of how much space it should take up. That should actually be 0.05. But it's how much space it should take up on the axis. So what's its relationship to the main graph? And this is the one you tweak if you're like finding it's a little bit too big or too small. Yeah.
So we've got 4 dimensions here.
Yeah.
The x and y, they've got axes.
Yeah.
We add a color bar, so that's got a kind of scale with the size. We kind of don't have a pretty scale or legend we can give.
Yeah, what you'll usually find is what people will usually do on like the fourth one for bubble is, I mean, this is where either it helps have like JavaScript rollovers, or you'll start annotating, or it'll be something where you don't really care about the exact size, but yeah, it's the relative size. Yeah, the famous thing with the bubble chart is like Hans Rosling's, yeah. Yeah, I mean, like I said, you can animate this stuff. There's a Matplotlib animate library for this. And it's, yeah, the actually only real difference is instead of saving to a canvas, you save to an animate canvas. Okay. Okay. So, do you guys want time to go through all the code? No? Or should I jump into the rest of the stuff? Jump? Okay. Any more questions on this stuff, though, first? Or any of the stuff we've covered so far?
Doesn't Matplotlib have hover? You said
It,
JavaScript.
yeah, Matplotlib does. You can do hovers and you can do callbacks to create it. Yeah, but then you have to work with one of the tool. Then I think you have to use like the TK intern, one of those backends. So the way to think about it is like I'm using ag here. Ag is perfect for like these batch jobs where you like need 100 figures for something, but like publication, like if you wanted publication, go with like ag or Cairo as your backend. If you wanted interactive, you need to go with like Tinker or HTML or whatever backend. And I think for 99% of people, it doesn't matter, or it not doesn't matter. I think like most of the tasks I've seen, you can get away with just the ag. But I don't, like, what's your use case? Yeah.
I use that in computing. We always do interactive blocks for users. Use it like MATLAB.
Okay. Yeah. Then you want Tinker backend. But I'm also thinking, I'm also wondering though for that if there's actually, I know I'm giving the talk on Matplotlib, but there's Chaco and traits, and that's the one that's really good for interactive stuff. If you want to stay in the Python ecosystem. It's Chaco and traits. Yeah, there was like lots of development on it like a year back, but I'm not totally sure. Yeah, CHACO. It was like, I think Enthought is the one who put it out. Yeah. I haven't like seen massive adoption, but it's like designed for interactive more than, because Matplotlib, it's kind of cobbled on the interactivity. Though granted, at that point I would also say just use JavaScript already. Use JavaScript for your data. Like if your data isn't too huge, just write your interactive interfaces in JavaScript, because Python will dump to you can dump into JSON really easily.
I think the Python notebook just added interactive widgets in its last release that just came out. And, you could probably do some stuff there. So.
Yeah. Okay. Any other questions?
I have a question.
Yeah.
About the marker.
Yeah.
If I want to set a marker to also be a random, and I select that, let's say I have 10 different types, and I just randomly select them, can I pass more than one marker type in there as an array? A, B, C, those are all arrays. Or do I have to plot each point one at a time and flip the marker?
I think Marco style won't let you do. There's actually an easy way to check this. I'm almost positive that Marco style won't let you, and it didn't let you. Yeah. Oh wow, this is not happy. Usually, yeah. Yeah, it's saying Marco has to be yeah. The documentation will tell you that it's not. You can always fix Marco. Okay. Oh, that's the other thing. The Matplotlib documentation is actually good. I know it's painful, but it is good. So it's like worth like just reading for like, see what you can do with it. Okay. So we're good with. So y'all are good. Good-ish. Okay. Ouch. So. Okay, so let's close out this one. Okay, so actually, look, before I go back, let me just remind you again that I'm losing my mind. Actually, Okay. Let me grab these. Close out all of these. Okay, we're going to talk about maps now. But what I do want to point out first is that, again, like anything we've been talking about, you guys can customize as you see fit along the way, right? You can, like I've been using gray face colors just because it's there. You guys can clean that out. You can also strip it away completely. Like if you need to dump something in LaTeX, you can set face off, and therefore you won't see any of it. It's clipped really tightly. Let me actually find. I mean, you'd have to look this up later, obviously, but. Oh, I'm using the wrong stuff. Okay. Never mind. Okay, maps, right? Let's talk about maps. So let's just start with making a basic map that we can just throw down, right? And so for a basic map, what I mean by basic map is just empty map. So this is where the base map library comes in. Base map is how you do maps in Python. There's also the Colorbars library, but I haven't seen like widespread adoption yet, and it's still kind of nascent beta-ish. So if you kind of just need something that works, use base map. If you want something that's a little bit better designed, Colorbars is more pure Matplot-ish. Like it's more in the style of Matplotlib than base map. But even then, base map is really kind of straightforward. The idea is that you create this base map object. That's your map. Everything you plot on the map. Everything you do, it's based around this map. And so you set up your map. And the way you set up your map is you set up the projection of the map. In this case, like it's a cylinder, and then you set up like what are your latitudes and your longitudes. And then it'll just draw the map. You also tell it, hey, I need boundaries and borders and meridians and all of that stuff. In this case, we're just making a plain basic map. And just raw. What was I gonna? Okay. Oh, but so let's talk about maps in together. Let's actually, forgot about this. Right. Map projections, they come in all types. So often your data goes on some kind of map projection. A lot of time it's in cylindrical because that's the cleanest. Sometimes you do need the whole sphere though. You'll need this kind of overload. So how do we control for that? Well, base map supports like everything under the sun. Yeah. So this is the list of projections base map will support. Your azimuthal, your geostationary, your Mercator. It's like if it's used by more than 3 people, I think base map will support it. But like I was saying, 90% of the time for what you need, I would just go with a cylindrical. The idea behind a cylindrical is just it's raw. Your matrix is a latitude and longitude point. You tell it, this matrix, this value is this at lat and lon, but it's just that raw. It's that direct mapping. So like if I did an imshow on your data, I would just be showing the world on that cylindrical projection. Okay, and so how do we start with this, right? So let's talk about actually putting points. So let's talk about cities. Hmm. So the way we plot cities on our map is we need to do this inversion thing. And what we're doing there is we have our latitude and longitude for a city. We pipe it into the object. And what it'll do is it'll take that latitude and longitude and it'll translate it to your actual points. Your regular, the points on the plot. And once it gives you back the, let me explain this better actually. Okay, you know we have a list of latitudes and longitudes? Pretend now that list of longitudes and latitudes are overlaid on your plot, your axis. And so your axis has these regular axis coordinates, these 0, 1, 2, 3, whatever. That's that matrix underneath, and it has the coordinates that go along with that, the indices that go along with that, these 0, 1, 2. And then you have your latitude and longitude overlay. And so they don't speak to each other. So if you try to just plot your latitudes directly on your map, it would probably, there's a keyword that to make it try to go right, but it'll probably go wrong. And so the standard way you do this instead is, like I was saying, you put your longitude and latitude in here, and what it does, it's kind of like taking that latitude longitude layer, smashing on top of the other one, and pulling out the right coordinates in x, y space, and it'll give you that x and y, and then you just scatter. And that's it for plotting your points. This is if you also want text. It'll just plot directly. Okay. And so yeah, if we plot that, that's what this looks like. Right, we're just plotting locations, and in this case, I'm tagging them with names to make sure I plot everything in the right place. You know, nothing ends up in the Indian Ocean. And then we have data, right? Data comes in two types, raster and vector. Have you all heard of this before? Right? Raster is that raw matrix data with a one-to-one relation, one-to-one point. Each grid cell has a value to it. Raster data is geometrical data. It's basically a formula. It tells you what the shape is, the size of the shape, and the relationships. And so we're going to first start by plotting raster data. So this is just a matrix. To do it, it's a regular old imshow. There's nothing, like there's no new magic. We do our mat, our m.imshow. And that's all we're doing to plot our data. Okay. Otherwise, we'll just throw in. So this is for all of these other diagonal stuff. And otherwise, we'll do, again, if the axis is one of the histograms, we'll, again, clear it out when we'll replace it. And so what we're doing here is we're kind of, possibly a mean way to say this, but like we're taking the structure of the Pandas graph, and this isn't true of Pandas, by the way, this is true of like any of this stuff. You can take that structure. If there's some like one little good thing you like, you can take that and use the entire thing as scaffolding for what you want to do on it. And that's what we're doing here. We're taking that graph, we're picking out the things we don't like, and we're replacing the things with a new image that's the same. And then we're doing a lot of this kind of cleanup of, you know, setting the labels and the locators and the formatters, because the goal here was to get everything lined up, right? We needed all of our x-axis and our y-axis to be of the same values. Okay. Oh, so that was the thing. So if for some reason you ever need like to inspect your labels individually, right? You don't need all of them. You just need some. You can enumerate over the labels. So there's this get labels method, get tick labels. So there's an x-axis and a y-axis method that says that you can just get those tick labels. And yeah, then you can just set the font size, and you can set all the properties individually. Okay. And same thing if you want to rotate stuff for whatever reason. Okay. Oh, let me actually, hold up. Just realized something. So I'm just realizing I think I have a cleaner, like just pure pandas example here. To you that we can do. I'll give it to you. If I can remember how this works. Okay. So what they're doing here is, so if we want like the parallel graph, and by the way, how all of this pandas graphing works is, so we start by making a date frame. The date frame is the pandas structured object for data. It's a glorified Excel table. It's kind of the way to think about it. It'll often have like a time series or categories or stuff, so it'll give us these dimensions on our data. Where it's useful is because like it's kind of glorified Excel table, is it can pivot, you can do pivot tables and stuff really easily with pandas. It also supports time series information beautifully, and that's the usual reason we use it. And so we'll make our date frame object, and then it's really as simple as calling the plot, calling the figure plot, calling the pandas function with the arguments it needs, and that's it. And then you just do a save fig, and you're done. Oh, legends. I forgot to talk about legends. Legends are, legends also, you can do like the basic, just a dot legend, it'll do it automatically. But like everything else in Matplotlib, it's got more keywords than it knows what to do with. So if you want it fancy, there's a fancy style keyword. If you want the location, it gives you the 9 possible locations. You can set the number of columns in your legend. You can set how thick the border is. You can set the face color, the edge color. These are all keyword properties to do it. I don't particularly want to, let's see. Yeah, if you ever actually look at the Matplotlib, it's like the legend library or something. Legend. Okay. Yeah. So if you ever actually look at this, they give you they give you some good examples of how to set this up. The only thing is with those examples are the usual, that those are the plot-based way. So the trick too, by the way, if you see stuff in plot-based, 99% of it, if it's in just the regular plot, you can do an AX dot and it'll work. If it doesn't, usually just do it. It's usually like AX dot set underscore whatever it is. And that's because on a practical sense, the PyPlot interface, which is the usual plot dot interface, is just a thin wrapper to the object interface underneath. Okay. Oh, and so remember I was talking about B-boxes before? So it's the same thing is here, is you're saying like where you want that legend box is, if you want it at the top or the bottom to be cleaner. Okay. So I think I know. I just found out material. I know, I have another hour. Yeah.
I have issues with like the x-axis when it's time. I don't know, like setting the date time.
I thought I had a sample of that. I know I have a sample. I may have skipped it.
Under this plotting this pandas hiding stuff, there's some symbols with like saying that 2009 but I don't know, I just
Yeah.
waste my time.
Yeah, no, what I'm saying is it's in the pre-baked code. One of these is 4 dates.
Oh, okay.
I'll go over it. I kind of didn't realize I had forgotten it. Okay. Yeah, yeah. Yeah. Oh, I forgot about function formatters here. Okay. I've lost something. Okay. Let's find the command prompt. Yeah, sure. Okay, again, before you leave, you all have to fill out an evaluation, and there's a link, and I think I have to share the link with you. See, desktop. Okay, so something else entirely. Okay, so yeah, this was working with text data. So, not text data, the numbers and function formatters. So let me start with dates. Matplotlib has a dates library. It's called the the dates library, and you import it using dates. Yeah, it's up top. mdate, or you import it as mdates. And so what this is useful for is if your stuff is in datetime already, it'll have day locators and month locators and year locators. So you can you can say like, hey, do dates, you know, give me my ticks, but here are the locators. And so if you find like your data is too crowded on a day, but you want it like every 6 months, you set the months locator to the interval to 4 to 6. And so you can use their locators to fine tune where your tick should be. And then they have the date formatter. And so the date formatter, again, it takes all, I think it's printf string, but it's the Python date time format string. So it'll take all of those options. So if you want like if you only want nanoseconds, or you only want years, I would just do years, and then I would get rid of this, and it'll parse directly just the year. Or if I just want the nanoseconds, only put the nanoseconds in the bottom, and it'll ignore everything else. Yeah, if you don't need any of that, don't put that in the format string, and it won't do it. So it's part of the dates library, it's the date formatter. So yeah, you can use that to just do your clean date and time formatting, and then you just set those as your locators and your formatters, and it'll under the hood. If you need more than that, that's where you get into just writing it, write the custom fixed locators and fixed formatters. But what I've found is that they've improved this enough that it should work for most cases. Okay. Oh, but also that's the other one. Like if you need to go very custom, that's where these function formatters come in. And the idea behind the function formatter is it's literally a function. You write a function that says, if you have this value, return this type of label. If I have this value, return that type of label. So you can, this is one of those easier ways to get like $signs and like to decide if my data is over this, use this amount of precision, use that amount of precision if my data is under this. But so that's the function formatter. The way it works is you write the function, and then you call your func formatter. That's your formatter, is the function formatter, and you pass in the function. And then you just set it as your formatter, and it'll do its thing. And so what will happen is every time it sees a value in your plot, it'll go call the formatter, and it'll call this function, and it'll return some value. So in this case, I had it just doing over and under. So that's what it did. It said like, hey, anything that's over is going to have that over prefix. Anything that's under is going to have that under prefix. This is usually useful if you have like some value you need to flag in your time series or something, or in your result list. Okay. And by the way, this figure is really cramped. So the easy way to fix it is you can change the fix size. And that's just, you go to the top here, and you so we can do 2010. And now it's wider automatically. So yeah, a lot of the aspect ratios start. I mean, there's also a function that you can pass in to give it for it to automatically set the right aspect ratio, but usually just changing the fixed size will fix it. So I just remembered something else I wanted to talk about. Oh yeah, that what is this? Oh. Yeah, if you want, like, if you need to make figures to dump them into LaTeX, can't be the only one who does. Oh, first, actually, let me talk about this first, because it's a little bit funner. Pictures, GIFs, right? If you want to make a GIF in Matplotlib, oh, I actually don't even need this. I think I have this. I just made this the other day. Hold up. Oh, where am I? Ah. Sorry, this is kind of so random right now. Right. So if I wanted a fit, if I wanted I'll save as. Okay. So the way these things work for that kind of, if you want to just animate things, is you say what you're animating based on. Control-Shift-K, Control-Shift-K. And that. Okay, so we have all of that. So the idea is we'll set everything to be a function of I. You know, so in this case, I have my stages that I'm making this GIF on, my stages of animation, so I can just, like, I need this value of the array, then this value of the array, then this value of the array. It's better for line plots. I'll plot that out. So you just do that, then you're creating this animation frame, and you're going to save to that frame, and that's it. So after you have your animate function, we write it. In this case, I think I wrote this to have t equals 200, so 200 frames. And I wanted to save. Write it to save. And I need some kind of argument. There's a window-specific argument. But you'll do that and it'll run. So you make the GIF. I think I deleted it. So I'm just like realizing I think I deleted the piece I needed for that. Sorry. Sorry, I'm like trying to remember what. Okay, so on Windows, because Windows hates people, you need to do this. You need to set your matplotlib.rc params and animate. Okay. Okay, so you set the GIF.
So those RC parameters,
Is-
to get back to what I was saying earlier,
Yeah.
that if you want to set global options for your axes to always do something,
Yeah.
that's how you set them.
Yeah, I don't ever recommend doing this except in this like case where it's like it's on Windows and I'm setting it, just because, I mean, granted, it's only going to set really for that call, the function that calls, and then it'll reset. But what happens if you're having a lot of stuff, like if you're doing a lot of different plots on the same script, it can get a little bit weird. But yeah, RC params are the global Matplotlib settings. So if like you always want your plots to like use Times New Roman or whatever, you just drop that at the top of your code, and for
Set the locale, and
yeah,
and not to use a comma versus a dot, you can set
yeah,
the locale.
yeah, it'll all go here. Trying to remember how this all works. Okay. I think that should be it. Oh. I've lost something. Okay. Okay, so lib. Okay.
Capital P.
Yeah. Case sensitive would be great. Okay. And of course I forgot to import the animate library. Where's this thing okay, let's just do that because I have way too much going on here. Okay. Yeah, and I'll throw this up on there in a second. So yeah, it's another library, Matplotlib, to do animation, and it's just the animation library. So that, and of course, so when your computer isn't mine, when your computer isn't mine, this should work. .exe. Oh, you just need the whole path. Full path on Windows. It'll do its thing. It'll make a little GIF. Oh, the other thing I wanted to talk about because okay, so while I'm waiting for this to finish, I'll do where you get this, how you can get, I have no idea what I'm looking for anymore. Okay. Okay. I think all of these are cleared at this point. Okay, yeah. If you want to get rid of the, like, all the borders and margins, it's these arguments, these bbox inches. Remember I was talking about bboxes? Bbox is the bbox is that bounding frame around your axes. So if you want to get rid of it completely, like if this is something you're going to throw in a PowerPoint or a LaTeX document, something you don't want to have to clip, do bbox inches equals tight and no padding, and you won't have that gutter frame around your plot. So if you need your raw plots. Okay. And this is like one of those many, many arguments that live in somewhere. And this will eventually plot. Let me actually throw this on some. Okay. While I'm waiting for this, yeah, GIFs take forever, by the way, so I don't actually recommend doing it. But sometimes, you have data or something that makes sense as a GIF. Questions so far? Yes, no, maybe? Okay, I think there's a set break now at 3:30. Oh, was it 3? Oh, you should have told me. No.
But there was coffee out there, so I guess we better get there before the coffee.
Yeah, so, yeah, and we'll come back and maybe this will finish and then we can talk. So, let's see. I should. Oh, okay. I don't have it here. So I'm trying to. Okay. So the way you actually do it, that's here. This way, this one will have it. It's a function called fill value. Let me try to remember which one it's in. Let me just try to remember which. But and I'll throw up a sample in your repo in a minute, or in a little while. But let me just try to remember where this one is. Oh, here. Okay, but yeah, if you want to do that, those fill value graphs, they'll literally just fill between. You do the axis, you do fill between, and it has you do the x value, the y value, and you tell it what's the condition for when it should do the fill. And that's straight. So let me see if I can find. Oh, yeah, yeah. Yeah, let me see if I can.
This is the cumulative max so far from stock price and where it is today. This is areas how far you are below the best you've been over this period.
I'm trying to remember where I.
I'm just thinking there's two lines and trying to fill the area between the lines.
Yeah, I'm trying to I did it, but I'm just like not sure where I dumped it. Not there, obviously. Not this one. Oh, hold up. Google is my friend.
Cumulative max is only increasing. So the top line, each of these graphs is the amount of time it's increasing. The stock price is today's
This is
price.
the agenda.
Which might have not,
See if I can find my own site. Ah.
this guy didn't make any money, but he didn't lose any money. These guys made some money once, but
Great.
then
Okay. So I know I should probably have my own slide somewhere practical, but this should tell you what I do in real life. So the come on. Okay, so yeah, the idea is to do these kind of graphs where you can, the idea is making these kind of graphs where you can fill in the data values between your x-axis and your y. And the reason to do this is, like you were saying, if you want to like highlight that something is positive, or you want to highlight that something is negative, or you want to highlight that, in this case, like how much is on each side of the zero in your histogram. And so like I was saying, to do something like this is, of course, so to make this is this fill between code, where you have your x, your y, and then your condition for where you're going to have that filling. Okay.
So like if you wanted to graph a certain color if the current price is below, and
Yeah.
then if the current, like, you do it depending on which line is above, have a separate color.
Y-
If at some point the
Yeah.
current price goes up above, but then you wanted to fill that,
Yeah.
positive color.
Yeah, that's what this is about. The t-stat, that's the y-axis. So you're basically creating this Boolean mask, like everything above, so everything in that t-stat that's greater than 0, we're going to fill with that color. And here, everything below, we're going to fill with that color. But these conditions are just any generic Boolean any generic true false array. So they can have any condition whatsoever. I can make the condition fill it where this is even or fill it where this is odd. And it'll be cool with that. Let's actually, nothing is, let's, there should be a figure. Let's see. Control V. Okay, so let's make one. X equals a fig dot add subplot. 1 1 x dot plot. I need a standard, like what's a sine curve? That's the example they have in the Matplotlib, by the way. A range 0 100 is equal to np dot sine x dot plot x x y save fill pi. What? I have to do. Oh, yeah, that. MP, so we can do that. Yeah. Okay, so we'll do that, and of course, and I think I now have this overriding my usual canvas. Okay, so that's a regular sine curve. It's a messy sine curve, but and 0.01, right? Let's do fine-tuned. Okay, so now if we want this in between, we can do ax.fill between, and we'll do the x, the y, and where, and this is our condition, where, yeah, y is greater than 0, and well, yeah, but what I want to do first is just set this ASH line. This is just so that we can get a good, clean x, y axis. This will AX, so that these VX line and V line and XH line. And the idea is that's when you need just a raw, line. AXH line will just give you a raw straight horizontal line. VX line will give you one vertical line. And you can do VH lines or V lines if you need multiple vertical lines at different places. Okay. Yeah, like V lines are good if you need to like do little discrete signal graphs, right? With pop. Done. Okay, what did I want? Let me see if this. Okay. So see, now I'll fill that up. And like I was saying, I can do this. It doesn't have to be 0. I can do it with y greater than 0.5. And we can do color equals red. And let's do another one of these for the flip side. And it'll fill up to the axis. Or where y is.
Is there like a hold command or something when you're plotting two lines?
What do you mean?
You're going to plot two different lines on the same axis.
Cosine curve and fill the area between sine and cosine.
Yeah, thank you.
There you go.
Oh. I don't think so. I think that you have to figure out your math yourself. With the here's hold up. Yeah. Stop plot. XC. Okay, so let's think of this condition. It's just if we can have a condition, then it's fine, right? So mask the idea is that it's in Y and it's in Z. Our point is, so how do we check that our point is in Y and it's in Z? Our point in Y is also in Z. Mask. Well, Y is less than. Yeah. So let's see if this. Like I think it'll try to do the pairwise comparisons there. Okay, let's see. Yeah, let me improve the fixed size because this is too small to see what's going on. Fixed size equals. Okay, so it's not totally right because we're still missing that other set. So you know what? Actually, there is a way. We're looking at NP. NumPy has an intersect. Intersect. Section of 2 ways. Here, that's what we want. Where Y np dot in 1D np dot in 1D Y is in Z. Yeah, that's the problem. We need this both ways, right? And np dot in 1D Z Y. We need where both of these are true. Okay. And then NumPy land, it's one of these is, right? Yeah. Sorry. Yeah. So. Okay, so the thing is we have to make a decision, right? So we're asking, we want this sign when it's less than this cosine, right? Okay. So we're, okay, for Y greater than Z. Z is greater than Y. Probably did do this and it just was hard to see. Yeah. Yeah, and now you're going to want to get rid of this, right? Only within this space. And so this is where what we really want is not X. We want the fill is not going to be between the X. The fill is going to be between Z and Y, probably. Or X, Y. Okay, so we have this, and then, so we want where this is true, but not where this is true, right? So we'd ask then, because the thing, oh, I know, 1 second. Let's look at the fill between documentation, because what we're really looking at is how to control the bottom of the fill between. Oh, this thing is slow. Okay. Oh, here we go. Here's how they This is the one you want, right? So that sample is, oh, we can have a y1 and y2. So they let us throw down the second one. And now you can just have that space. Yep. And we can, if we want the other half, right? Let's say we want red. Let's make this yellow, and this is where. Okay. What did I lose? Oh. Yeah. And then you'll get your other half of it. Okay. Let me see if this animation finished ever. Do we have a GIF now? Ah. It sometimes doesn't like to display GIFs on me. Does Imgur display GIFs? Okay. So that's how this one works. Like I said, this one's just a straight swirly thing. Projectile motion. Okay. Oh, and the stylings. So there's kind of, I don't know if it was someone being very bored, but you can apply an XKCD style to Matplotlib. And so this is the XKCD style Matplotlib. That's why it's all curvy and fuzzy. Yeah, it's actually, like, that's the easiest thing to do. Let's grab this. If you want XKCD style for whatever reason, you just do plot.xkcd, and it overwrites all the RC params with the XKCD ones. And then, like I was saying, this case I was just doing projectile, an Archimedes spiral, so the spiral functions, apply that, get rid of a lot of spines, clear out my tick, and then it's like we clear out our spines, we clear out our ticks, set the X and Y limits to, I think, 0 to 1 again, or something like that, X line and V line, so I can have a clear center axis, and then plot. And the idea behind these animations is you put all your plot code, everything that's going to be a frame, like anything that gets updated as a frame, goes inside a function, and then you pass in arguments that will update with the frame accordingly. And then you can animate and save. If your GIF doesn't want to work like this, what I've taken to doing is you print out your whole slew of PNGs, and then you feed that into GIF to the case where this is really useful, and this is where I've done it, in a practical sciencey sense, is, let me find that again. What I've done it for science is the Matplotlib 3D images, 3D scatters. If you've ever worked with Matplotlib 3D scatters, you find that they're horrible. Like, you can't rotate them, and so you can't do the views. So what happens? So there's this property called the azimuth, and the rotation is so you can rotate your figure. So what I've done before is we'll rotate the 3D figure, and we'll save that as a GIF. And now you actually can explore your 3D data sets better. Let me see. Okay. Yeah, so this ax.view initial, that's the elevation and this azimuth. And like I said, you can rotate them. You can rotate the elevation and you can rotate the azimuth to get if you want to start seeing different perspectives on your image. Okay. Any other questions? Questions? I'm gonna dump it for you guys, yeah. And let me dump the fill code, add the fill code too. No, wrong thing. Okay, so let me, you're gonna go in here. Try to delete the wrong thing. Okay, fill is in here now. Yeah, all of that. Okay. Any other questions while I sort this out? Anybody else have any other plots they're interested in making? Ouch. Anyone run into any common problems when they're trying to make images? Oh, yeah, there are two things to do. One, you can use a color map. You can feed the color map in as the color argument, and it'll automatically choose from there. That's one way to do it. The other thing you can do is there's this Matplotlib has a color cycle function, so you can have it color cycle through. The third thing you want to do, and I'll dump the code, but there's so the problem you have when you're applying a ton of lines on something is that the colors aren't distinct, right? And then it's hard to blur. So a lot of people have written different code that solves this. Like I said, I'll dump for you. And what it does is it looks in the color space. It projects into the color space. So it takes all color and puts it on a ball. And then it picks one color, and then it picks the next color, as far away from it as possible, and then picks another one as far away from possible, so that these codes will generate distinct colors.
Is there a way to, because sometimes you want to plot, for example, say, different, each of the lines correspond to a different parameter. So say that you want to run, some temperature or something like that. So you want the cool temperature to be blue, and the other one, the hot temperature to be red.
Oh.
Is there a way to pick up, an easy way to pick up these colors and say, and then I want the central temperature to be green, something like that?
You might,
The way that I found is just what you said, you have random colors.
so I think, let's try this. Okay. Don't totally take my word for it, but I think we can just do a color map. Yeah, so that's what I'm trying here. So let's do MCM. TVU. Okay. I forgot what my file name. Oh, line map, C map. And in this case, we probably have to set C equals to a value, a Y value. Mm. Color. The color map line. Oh, yeah, see? Oh, yeah, so I'll do, that's what they want. This is more work than it's worth. But what you're doing is I'm just going to talk about his code because it's easier. You're doing is you're going backwards. You're saying, okay, I have this color map, I have this normalization technique. I'm going to take my color map, I'm going to take the values I need and build out that normalization. Like I need these things to map, and I'm going to have my color map jet. And so what I'm going to do is I'm basically going to build myself. Given this color map and given this color map and given this normalization, give me back a list of this number is going to be this color. That's the scalar mappable. So this number is this color. And then basically take that scalar mappable, get my actual numbers. And so then I'm going to enumerate over that list, and I'm going to there's way too much stuff going on here. But then it's just going to plot that. Like you're basically plotting each X and Y individually. But you're letting Matplotlib take care of the color, the actual how do I color this.
Where do you change the color to like an alpha sort of?
Oh, if you want to see see-through? Yeah. It's just the next value over. You type in, it's like alpha equal. And that's, yeah. Okay. Yeah, so you see now they'll kind of go through the curves. You can also do these, actually where this gets useful, and you'll often see it, is in these fills. That'll just like, and that's how also if you want the faded look. Let's see, let's get it. Anything else? Let me see something. Oh, he's still doing separate lines. Okay, let's see if there's. Okay. Oh. This is cute. Yeah, so they're doing like just a clean color map, and then they say like make segmented line plot and plot them individually. But thing is, like I'm looking at that, and by that point it's more work than, you know, writing a little for loop to iterate over your sections. Okay. Any questions? Things you want to know how to do? Sure.
I don't really program in
Okay.
In MATLAB, one of the things I run into is if I have nested graphs where I call one function and then I'm graphing multiple things. If I saying figure one,
Yeah.
they kind of they have issues with each other. I'm wondering in Python, how do you kind of mediate that if you call it figure one?
That's why you do the object-oriented way instead of the state-based way. Like all of that, like all that figure madness you have is because in Matplotlib, it's doing that state-based model where the figs are just like popped up there, so they sometimes will lose their reference. But in Python, like if you explicitly say, hey, this object name is attached to this object, this fig subplot object, anything that happens on that figure object stays with that object.
Yeah, I see. So you just call it big.
Yeah.
Is there something similar to like hold all or hold on this in terms of, I don't know, in Mac?
No, I know what you mean. It's one of those weird ones where you don't, for the object-oriented, you don't need it. If you're doing it this state-based, I think there is, but I'm not totally. Okay, yeah, there is.
I'm used to like plotting multiple, like I'm calling the plot function multiple times and it's writing over on the same graph. So I like,
No.
generate my background and then I'm plotting multiple lines
Yeah.
on that background.
No.
And it uses the same background. I wasn't sure.
Yeah. So you wanted to use the same background or different background?
Same background.
So, yeah. In usually, like in Python, what you'll do then is like you'll just write to the same axis. If you write to that axis and it'll be fine. If you're not doing the object-oriented, if you're doing the state-based, it's just going to go to the last thing it saw. But I think if I Google this correctly, there's a directly, I don't like this, but whatever. There's like for a lot of that stuff, there's a direct analog. So you'll have, we'll do a plot.show. Let me see. Yeah, you can have hold, and it'll just work the same way. And it's the plt.hold, because if you're going directly from MATLAB to Python, the PLT interface is, I think, tries to use the same commands when possible. Okay. Any more questions? Questions, comments? You have data you want? Otherwise, I posted the link for the evaluation. You're supposed to fill that out. Okay. Okay, so the deal with the normal probability plot is they're supposed to be kind of, they're called Q plots, and the idea is it's supposed to tell you how close the distribution of your data is to normal. And so what they're doing is it's a scatter plot. It's a scatter plot. It's your data sorted compared to if I was going to take a if I was going to take the values of your data and I was going to evaluate, if I was going to look at the if I was going to build this little normal curve over your data, over your values, and look at those probabilities.
Can you give us an example of a
Yeah.
table? Yeah, some context of like,
Oh.
an example. I don't know.
Okay. Well, no, that's fine. That makes sense. Okay. So what's happening here, like here for like what I was looking at was Viva deltas, and I was looking at, I have no idea what. No, I know, like I'm looking at the Amazon and I'm looking at like rainwater, I think. Actually, no, this here I'm just looking at random data. But what I'm doing is, so I have my random values, right? Like, you know, all 20 values, and they're just purely random. If my random, so I sort them. And the thing I know about if I sort my values is, you know, there's going to be regular values. But then what I want to do is I want to then take the build, like given those values, what's the probability of them occurring in like a normal distribution? So that's taking the probability distribution. Yeah. So this is the probability of those values, of the probability of these sort values occurring in a sorted array. And so what we want to see is, in a normal distribution, so let's go back for a second. Okay, so we have, you know, okay, let's say that this is rain, right? Why not? How much it rained today? How much it rained in the past week? And we're sorted from no rain to large rain. Now, what we're doing with X is we're saying, okay, given I have, given I have 12 inches of rain, and given a probability, a normal curve, right? So given a normal curve over like all rain from my values. So given like, if I had like zero, like from a normal curve that went from 0 to 20. What's the probability of that 12 happening? Like where would that, like if that 12 is on that x-axis, what would the y value be? So that's what's happening here with these probabilities. It's telling me the probability of this value occurring given if it was a purely normal distribution.
And when it takes in y as the parameter, it
Yeah.
automatically chooses the range for where that normal
The mean and
Well-
standard deviation parameters for
Well,
normal.
because it's passing in y as a list. So,
So the normal is going to compare to is the one that has your mean and standard
Yeah.
deviation.
but that's
Yeah.
given in y.
yeah, because y is the list of all. Yeah,
And
Yeah.
the standard
Yeah.
deviation of the list.
Of y.
yeah,
I see.
It's
Yeah.
just that theoretical normal.
Yeah.
But
Yeah.
that's theoretical normal to your empirical normal.
yeah,
I see.
yeah.
And so the x-axis here is the,
Is the sorted data.
and then y is the probability.
Yeah, the probability of this data given a normal, given if your data wasn't normally distributed.
That extreme from a normal
Yeah.
to a mean and standard deviation.
Yeah. And the thing with the Q plots is they don't have to be normal. You can, like if your data, you know, is Poisson, you do the same thing, but use Poisson instead of normal. Or if your data is Bernoulli or whatever.
Okay.
Yeah.
Look on Wikipedia for QQ plot, quantile
Yeah.
plot.
Oh, yeah, the thing I used for referencing all of this, and I should actually link to you all to, is the National Institute of Standards and Technology, NIST, they have an EDA handbook. It's great for like all these plots. There. You don't like me. SDA. Okay, so they have, it's their handbook, the engineering statistics handbook. So they have a whole section on like all of the exploratory data techniques. So they have all the plots there. And it's like really clear on what they all take. I'll throw this up on the class notes. I'll throw a link to this up. Um, um, okay. Okay. Oh, let me. Any other questions? Questions? Okay.